Okay, this is lesson 1.3. We are talking about odd and even numbers. This is part 1. So we call groups when we can have numbers that can be evenly put into groups of 2. Those are called even numbers. If we cannot put them into groups of 2, so if we can't, they are odd numbers. So we're always trying to do groups of 2 with nothing left over. Okay, groups of 2, nothing left over, those are even numbers. Okay, but if you have something left over when you're making groups of 2, then it's going to be an odd number. So here's the first way we can do it. We can use manipulatives. So if we just have some checkers, you could use coins, you could use whatever you want. You could take 10 objects. Okay, so right now we've got somebody that chopped up their little thing, their nibs into little, their...
Nibs.
Yeah, they took their, what's that thing called?
Nibs.
Licorice, a piece of licorice, and chopped it up. So if we chopped a piece of licorice up into 10 pieces, then we would separate them and see if we could put them into groups of 2. So 10 checkers, we have 5 groups of 2, and we have none left over. Okay, none left over. So that means that it is an even number. Okay, so that's how 10 becomes an even number. Now, if you remove any of the 3 checkers, if you take 10 and subtract 3, you get 7. So if we do groups of 2 with 7, we get 1 left over. So if we ever get any leftovers, it means it's an odd number. Okay, so always trying to make groups of 2. Second strategy is to just use your calculator. So we can enter the numbers and then hit the divide key. Whoopsie. Hit the divide key. Turn your page, please. Hit the divide key and divide 2. So when you're dividing by 2, again, if you get a number that does not have a decimal, so if it does not have a decimal in the number, it's an even number. But if your answer is displayed with a decimal, that means it didn't divide evenly, so you couldn't put it into even groups. So that means that number would have had leftovers, which makes it an odd number, okay? So the first example here, if I put the number 75 into my calculator and I divide it by 2, I'm going to get this answer right here, 37.5. Okay, so again, when we hit the number 75 into our calculator, we divide it by 2. The number we see has a decimal. So I have 37.5. That means my number is odd because I have a decimal in my answer. Now, something we could also do is look on the far right-hand side of the number. If you look at the far right-hand side of the number and look and see if the numbers are odd or even. So we can make a list of odd and even numbers. So if we say our odd numbers are 1, 3, 5, 7, and 9, there are 5 odd digits. And if we make even, there are also, so 0, 2, 4, 6, and 8. We have 5 digits as well. So 10 digits, 5 are even, 5 are odd. And those 10 digits will create absolutely any and every number. So it says, look at your very last number, and we'll check and see which list it belongs in. So if I look at the 8 can be divided by 2, and it's in my even list here. So that means we're going to get an even answer. We're not going to get a decimal answer when we divide by 2. All right, moving on to part B. Whoops. Okay, moving on to part B. Multiples. Multiples are numbers that can be divided hang on. Multiples are numbers that can be divided, I needed more space, evenly. So divided evenly by other numbers. So that means no decimals. Okay, that can have no decimal answer. That's what that's telling us. So if we use strategy 1, it's saying use your calculator. So it says multiples. What is the definition of a multiple? They are, well, what do you think? It says multiples are the product It's a big word. Product. So multiples are the product, which is the answer of multiplying two or more factors. Well, I'm going to ask, how the heck do we do that? So we need to be able to figure out how to do that. So it says we start by taking our number and we multiply it by 1, and then we multiply it by 2, and we multiply that same number by 3. And those become the new values, and those new values are called multiples. Whoopsie. Multiples. So those new numbers are the multiples of the original number. So if I look up at my first number, so it says, what are the first 4 multiples of the number 4? Well, this strategy tells us I'm going to go times 1, times 2, times 3, and times 4. So 4 times 1 is 4. 4 times 2, 8. 4 times 3, 12. 4 times 4, 16. So I'm going to write my numbers as a list now. 4, 8, 12, and 16. So that's one way to find multiples. So we take our first number, we take our original number. Okay, so this is our original number was number 4. Okay, so you always start with your original number. And you would multiply by 1, by 2, by 3, by 4, and you'd keep going with that pattern. Now, we could also use a calculator. So if we wanted to use a calculator, we could also do it by skip counting. Okay, so we can skip count. Well, how? How do you skip count? That's what we got to figure out. How the hay bales do I skip count something? Well, it says take your original number and add the same amount every time. So if I took that number 4, my original number, and I add 4 every time. So I start with my original number, and then I'd add 4. I'd get 8. I'd add 4 more. I get my 12. I add 4 more. I get my 16. And I could continue this pattern by adding 4 every time. So we could find the numbers from the first scenario by multiplying by the digits 1, 2, 3, 4, etc. Or we could skip count and just add the same amount every time. Both can be done. It doesn't matter which way you use it. You can do it either way, whichever makes most sense to you. So now it says multiples can be represented in, what can they be represented in? Well, they can be represented in lists or sets or groups of numbers. Okay, so lists, sets, and groups. Well, we got to find out what lists are. Okay, so let's turn our page and find out what lists are all about. So it says lists are written in order, starting with your smallest number and going to the largest number. So we are starting small to big. So if I look at my first example, it's showing me the number 5. And then I've got 3 numbers. It says 5, 10, 15. What are we counting by in this one? We're counting by 5s. So we could add 5 every time. I would get 20. Add 5 more. Get 25. Add 5 more. Ooh, that's getting glitchy. Hang on. Add 5 more and get 30. Okay, and I'm going to put dot, dot, dot. Those 3 dots at the end, these mean the pattern continues. So it literally means and so on. So for those 3 dots, they literally mean and so on. It keeps on going, that pattern. We're going to look at the number 7. We're going to do the exact same thing. So 7, add 7, we get 14. Add 7, we get 21. I'm going to add 7 more and get 28. Add 7 more, 35. Add 7 more, 42. Now I'm going to do the next one by multiplying. Okay? So this one we were doing them as skip counting. Now I'm going to do one as multiplying. If we're doing by multiplying, I'm multiplying by single digits. So I'm going to multiply by 1, then 2, then 3. Well, this guy was times 1, this guy was times 2, this guy was times 3. That means the 11 was times 1, times 2, times 3. Now I'm going to go 11 times 4 and get my 44. 11 times 5 and get my 55. 11 times 6 and get my 66. So there are a number of different ways you can create multiples. It says sets are written using a colon and curly brackets called braces. The braces actually tell us that the numbers inside the braces belong to a set. So whenever you see these curly braces here, that means the numbers inside belong to the same set. Okay, so we're doing the set of 8. A set of 8, you put your brackets, your curvy brackets in, and then again, you could either skip count or multiply. So this guy, I could have went 8 times 1, 8 times 2, 8 times 3, 8 times 4, etc. Or I could have went 8 plus 8, 16, add 8 more, add 8 more, add 8 more. Because the skip counting, they're adding 8 every time. Okay? So we can skip count or we can multiply. They both work. All right. It says, if a specific number of digits in a set is not asked for, you always write the first 3. Okay? So if it just says, write a set of multiples, and it doesn't tell you how many, you write the first 3, and then you put those 3 dots that we talked about a minute ago. And those are your 3 periods there. That means the pattern continues. And again, like I said, in words, it means and so on. The pattern continues and so on. So we're going to write the first 5 multiples of 9 as a set. So I've already drawn those curvy braces brackets in for you. And now what I want you to do, I'm going to give you a couple minutes. I want you to write those first 5 numbers. You can either do it by multiplying or by adding. Okay, so we had a few minutes to take a look at the number 9. So we start with our very first number. So whether you added 9 every time or if you times, this guy would have been a 9 times 1. Then you would have had a 9 times 2 to get 18. Then 27, then 36, then 45. So everybody should have those 5 numbers.
I actually got it right.
Well done. Okay, last section here. We're going to talk about the lowest common multiple. So the lowest common multiple of a pair of numbers. So this is when we are comparing 2 numbers. So this is when we compare numbers. So there needs to be a minimum of 2. Minimum of 2 numbers. Okay, we need a minimum of 2 numbers in order to compare them. Otherwise, we're just talking about one thing. We need to be able to compare them, so we need 2 different numbers. So it says it is the smallest multiple that is common to both. That's what we called our LCM, lowest common multiple. So we have an example here that says hamburger patties and buns are often sold in different quantities. To purchase exactly the same amount of patties and buns, we need to be able to locate or calculate the lowest common multiple of each package because they are sold differently. So how do we find the lowest common multiples? Here's our 2 steps. We only have 2 steps. So step 1 says create lists or sets of your first 5 multiples. And this is the important part. Starting with the larger number on top. Then it says you're going to circle the smallest one that they have in common. So that means it's in both lists. That is your LCM. That becomes your LCM. All right, so here's this example about our hamburger patties and our buns. So the patties are sold in packages of 6, but the buns are in packages of 8. Question?
Can I use the bathroom?
Yes.
Thank you. BRB.
Okay, so it says we have 2 different numbers, packages of 6 and packages of 8. That means we need to make our lowest common multiples. So we need to make our lists. I drew the sets for us. So we start with our first number, 8 and 6. And now I either skip count or I multiply. So 8 times 1 is 8, times 2 is 16, times 3 is 24, times 4 is 32, times 5 is 40. So we make our bigger number on top. We do the first 5. You need to do a minimum of 3. We did 5 for this example. Now we do the smaller number. And the smaller number, we don't need to make the entire list. You only make the list until you reach the number that matches the one on top. So if I get a number now that comes next and matches on top, then I can stop.
I know the number.
So we're going to go 6 times 1 is 6, times 2 is 12, times 3 is 18, times 4 is 24, and I can stop because I found my numbers that match. 24 matches, so I don't even need to finish my list. So now I know my number is 24. Now, if that's 24, how many patties and buns do we need to have an equal amount? We would need to buy how many patties and how many buns? Well, we need 24 patties and 24 buns to have an equal amount. Okay, 24 of each. Well, we've got some that are sold in 8 package and some are sold in 6. So this is where we divide. This is the important part in this one. This is where we divide the number by the size of the package. So we divide by the size of the package. And that'll tell you how many you have to actually buy. So 24 divided by 8 is 3, and 24 dividing by 6 is 4. So that means that the buns in packages of, let's see here, what did it tell us? Patties were in 6. So this is our patties, and this is the buns. So it's saying that we need to buy how many patties? Well, 4 packages of patties, because 4 times 6 will give me a 24. And I need to buy 3 packages of buns. Okay? All right. Okay, last example. What if we organize information in a table? Sometimes using a table is time consuming. So usually making our LCM skip count lists is easier, but sometimes tables, if we have a lot of different items, then it is easier to use a table. So let's take a look at this example. We're having friends over on Saturday for a few hours in the afternoon. You want everyone to get the same amount of snacks. You want to purchase chocolate bars that come in packages of 4 and drinks that come in packages of 6. How many packages of chocolate bars and drinks do you need to buy to have the same amount of each? Well, let's start with our chocolate bars. So our chocolate bars are in packs of 4. So 1 pack has 4. So then how many packs would 2 packs have? I would add 4 more. How many would they have? 8. And I would add 4 more. They would have 12. And I'd add 4 more and they would have 16. Now you could have also went 4 times 2, 4 times 3, and 4 times 4. Okay? And that's how you can also get those answers. That's glitching out pretty good there. Holy. Okay, now with the drinks, we're going to do the exact same thing, only this time they are in packages of 6. So our first number is a 6. If I were to add 6 more or multiply by 2, I would get 12. And guess what? That's the number. I can stop. Now, do I want to fill the rest of the chart out? You usually should. So I'll put my last 2 numbers. But really, we already found the numbers that match. So you can circle them. You can highlight them, whatever you find easiest. But we did see in the chart that 12 is the common number. Okay, so it looks like we need the number 12. So that is our least common multiple. So now this means how many packages of chocolate bars do I need to buy? Well, I look at that and that tells me I need 3 packages of chocolate bars. And I look at my drinks and my drinks are 2 packages of drinks. So we use the method. So it says using a table can be time consuming, which is why we usually use the LCM by creating lists or sets. Okay? Now, tables are excellent to use when comparing 3 or more items or numbers. Otherwise, it can be super confusing. So tables work really well when we're using multiple different types of numbers. So if we use way more than 3 numbers, if we have 7 or 8 numbers, we might want to list it in a table so the data is organized for us. That concludes lesson 3. You can now have time to work on your assignment.